Hey everyone, and welcome back to the channel. Imagine, for a moment, a world that simply shouldn't exist. A cosmic anomaly so profoundly baffling, so utterly defiant of our most cherished scientific principles, that it compels us to tear up the textbooks and rewrite the very rules of the universe. What if, tucked away in the inky blackness between the stars, our most advanced eyes in the sky, the James Webb Space Telescope, just found exactly that? A planet, a colossal gas giant, orbiting its star in a way that's impossible, with an atmosphere that defies all logic, and a very existence that laughs in the face of planetary formation. This isn't science fiction, though it feels like it. This is the reality being presented to us by the Webb, a reality so startling it sends shivers down the spine of every astrophysicist. For millennia, humanity has looked up at the stars, wondering what else is out there. Now we're finding out, and the truth is far stranger, far more complex, and infinitely more mind-bending than we ever dared to dream. The James Webb Space Telescope, or JWST, is more than just a telescope. It's a time machine, an atmospheric detective, and a cosmic cartographer all rolled into one. Launched on Christmas Day 2021, this marvel of engineering orbits nearly 1,000,000 miles from Earth, wielding a segmented mirror almost 21 feet across. But its true power lies in its infrared vision. Unlike its predecessor, Hubble, which mostly sees invisible light, Webb specializes in infrared, allowing it to peer through obscuring dust clouds, observe the faint light of the universe's earliest galaxies, and crucially for our story today, analyze the atmospheres of distant exoplanets with unprecedented detail. It's designed to answer some of the biggest questions in astronomy, and it's doing so with a flair for the dramatically unexpected. Before Webb, our understanding of exoplanets was already undergoing a revolution. For centuries, we only knew of the 8 or 9, depending on your stance on Pluto planets in our own solar system. Then, in the mid-1990s, the first exoplanet around a sun-like star was discovered, 51 Pegasi b, a hot Jupiter orbiting incredibly close to its star. This discovery shattered our preconceived notions, proving that planetary systems could be vastly different from our own. Since then, thousands more have been found, ranging from rocky super-Earths to massive gas giants, from planets with 2 suns to rogue worlds wandering through interstellar space. We've cataloged a dizzying diversity, leading us to refine our models of planetary formation, migration, and evolution. Yet, every now and then, the universe throws us a curveball, a planet so utterly bizarre that it forces us to rethink everything. And that brings us to the recent, jaw-dropping findings from the Webb telescope concerning a system now informally known as Erebos Prime. Imagine a team of astronomers, hunched over their screens in the dead of night, sifting through the torrent of data pouring in from the JWST. We're targeting a system in the distant Auriga constellation, a fairly typical G-type star named Solera Prime, slightly larger and hotter than our Sun. Initial observations using the transit method, where a planet passes in front of its star and causes a slight dip in brightness, had already indicated the presence of a gas giant. This in itself wasn't groundbreaking. Webb has confirmed hundreds of transiting exoplanets. But as the data accumulated, an anomaly began to emerge. The dip in starlight was substantial, indicating a planet roughly the size of Jupiter, a truly enormous world. This was the first shock. The next step was to use the Webb's advanced instruments, specifically the near-infrared imager and slitless spectrograph, NIRISS, combined with ground-based radial velocity measurements to determine the planet's mass. This is where the story of Erebos Prime takes a turn into the truly impossible. When the numbers crunched, the scientific community collectively gasped. This Jupiter-sized behemoth, this monstrous shadow passing before Solera Prime, had a mass of less than Saturn. Let that sink in for a moment. Picture Jupiter, the king of our solar system, with its immense gravitational pull and swirling storms. Now imagine a planet of that same colossal size, but weighing significantly less than Saturn, which is already the least dense planet in our solar system. This makes Erebos Prime a superpuff, taken to an extreme, a planet so incredibly low density that it would float in water, if you could find a bathtub big enough. Its density is so low, it's barely above that of cotton candy, if cotton candy could condense into a planetary sphere. And then there's its orbit. Erebos Prime hugs its star, completing a full revolution in just under 2 Earth days. This means it's incredibly close, subjected to an inferno of stellar radiation and powerful stellar winds. How can something so large, so ludicrously low density, survive such an environment without being ripped apart, boiled away, or simply evaporating into the vacuum of space? Our current understanding dictates that such a world, if it formed at all, should have its atmosphere stripped away in short order, leaving behind a barren core, if anything. Yet, Erebos Prime persists, a defiant, puffed-up enigma. But the story of Erebos Prime's impossibility doesn't end there. This is where the Webb telescope truly shines. Its spectroscopic capabilities allow astronomers to analyze the starlight filtered through the planet's atmosphere during a transit, revealing its chemical fingerprint. And what Webb found in the atmosphere of Erebos Prime unleashed the second, even more profound shockwave through the astronomical community. Against all odds, the Webb detected clear, strong signatures of complex molecules that simply should not be there. We're talking about specific hydrocarbons, intricate organic compounds, and even tantalizing hints of water vapor in an environment where, by all known photochemical models, they should be utterly incinerated by the star's intense ultraviolet radiation. The atmosphere of Erebos Prime should be a stripped-down, hydrogen-dominated wasteland if it managed to cling to any gas at all.